Good afternoon, everyone. In this lectures, we are going to discuss about how we can use the MATLAB built-in functions to solve the ordinary differential equations. So first we'll discuss about how to solve a first order differential equation, and after that we'll see how we can use how we can use the MATLAB to solve the simultaneous differential equation, and then how we can convert the second order differential equation in a form of simultaneous differential equation to find out the solution of such given problems. So we'll basically going to discuss about the solution of ordinary differential equations, which is also known as ODE. So in case of ordinary differential equation, how you write any differential equation? In first order differential equation, normally you write, say, dx by dt is equal to, say, you are writing x plus t. Okay, so the moment you are writing a first order differential equation, you also know that if in order to solve this kind of first order differential equation, you need some initial conditions, like what is the value of x when t is equal to 0. So if it is a first order differential equation, you need one initial condition, and if it is second order differential equation, then you need two initial conditions, and so on. So since it is a first order differential equation, in order to solve this equation, we need one initial condition, that what is the value of x when t was 0. Say for time being, I am taking this consideration that at t is equal to 0, the value of x was 0. So this differential equation basically going to represent how the value of x is going to depend on the value of t. So here x is dependent variable, t is independent variable. So for time being, we can also assume that t is representing the displacement of any particle at different given time t, and that is given by x plus t. So this is first order differential equation, and in this first order differential equation only you can see what are basically the inputs. The inputs are this function. Okay, the input is basically this one, the given initial condition. And what is the another input? The another input is the solution, the value of t at which you want the solution of this equation. If you want to solve this, basically you want to find out what is the value of x at given different time t. This is basically the solution of this given differential equation. It means if you want to solve this differential equation, you need three input parameters, and those input parameters are the function, the initial condition, and third one is the value of t time t at which you want the solution time. So similarly, the MATLAB has also written provided some inbuilt function to solve the ordinary differential equation, and in that ordinary differential equation you will see that will ask for the three inputs, and it will give you the one output. What are those functions? There are a number of functions. I'm just going to discuss here the two functions. One is called ODE 23, and another one is ODE 45. ODE 23 and ODE 45. As we have seen here, we have three input parameters. Here also you will see in the given the command which is ODE 23 and ODE 45. It will basically ask for the three inputs. One is the function, the second one is the time for which you want to solve the you want to find out the value of x. So let me write this as a t span, and then this the initial condition, which is x0. So in ODE 23 and in case of ODE 45, in both the cases, the inputs the input required are three inputs. One is the function, t span, and the initial conditions. ODE 23 and ODE 45 are basically based on the two the RK methods. One is the second, third RK method. This is called fourth, fifth RK method. So they are basically written on the numerical the Rangakata method. Now, so this is how you write the syntax. When you write this and you give the input, it basically gives you the output. And what are those outputs? What are those outputs? What are those outputs? The outputs are basically you write here T, and if you write here Z, okay, this is basically time, and in this variable it will basically store your output, which is X. So whatever the name you want to write it here, you can write the name. So the first the variable which you enter in this square bracket will actually correspond to the time at which you want the solution. The time at which you want the solution. So whatever the t span value you will enter here, that will be stored here, and at this given t span, whatever the solution of x is there, whatever the solution of x, that will stored here with the variable name. Whatever the name you want to write, you can write it here. Similarly for this function as well, you write t and z. Okay, t and z. So what I will try to do, I'll just try to solve this first differential equation, dx by dt is equal to x plus t with this boundary condition. I'll write the program here, and then I'll write the program in the MATLAB and show you how to solve this first order differential equation. So let's begin with this. You know what we have, what is the function? So this is your function. So write this function, we can also give this name. This is also called x dot. So let me write this as a x dot. So in the program, what we first need to write, we need to write the initial condition. So let me write in the initial condition, I'm writing with x0, and that x0 is 0. So first I'll write x0 is equal to 0. Then the time at which we want the solution, is given with the name, say t span. So I'm writing simply here t span. Suppose I want the solution between, at time between 0 to 10. So if you write 0 to 10 here like this, you just need to be careful about the t span. The element cannot be 1, the element should be more than 1. At least 2 elements should be there, and if you enter 2 elements here, it will automatically generate the different points between this 0 and 10. Okay, and it will do the calculation. If you give only 1, it will give you error. And if you give more than 2, like say you are giving 3 elements and 4 elements, so at those points only it will do the calculation. So we have given x0, we have given t span, and next is what? X0 we have given, t span we have given, next is the function. And let me write the function name is x dot. So I'm writing it is x dot, and that x dot is x plus t. So I'll write here x plus t, and after that just simply I'll write here, say t comma z, whatever the name you want to write here, t z, and say I'm using the solver, say ODE 23. So you can write ODE 23, you write here x dot. Okay, you need to define a function. So you can write x dot, this function you need to define. So you write this x dot. X dot is a function, and that function is function of x and t. So it is x plus t, and here you write x dot comma your t span, and then you write here x0. It will solve this. This will basically solve the first order differential equation, and your output will basically going to stored at a given time t in this as a column vector in the variable name z. So after this, if you want to just see the solution, you can write plot. Okay, you want to see the what is the value of x at a given different time t. So you write t comma z. If you plot it, it will give you the solution. If you want to write something here like what is on the x-axis, y-axis, that you can easily write. So I'll just use this MATLAB, I have already given the name of this file, that is ODE underscore first underscore order. So this is, we are going to write this program, we are going to write for the ODE ordinary differential equation of first order. Problem I have already defined, so directly I'm writing what is x0. My x0 is 0. Okay, then I have defined the t-span, the time at which I want to find out the solution is say 0 and 10. Then I'm writing x dot, the function, that x dot is the function of x comma t, and that is your x plus t. And after that you want to see the output, and you want to store that in z. So I'm writing t in z, and the solver you want to use say ODE23. ODE23, first element is x dot, then you have t span, and then x0. If you use this, it will use the ODE23 to solve it. Suppose you also want to solve it by using ODE45, and say the name you want to write, say T1 and Z1, and I'm writing ODE23 and ODE45 just to plot both the solution by both the solver. So we can write say plot, this is T comma Z, and you want to write the title for this solution, or what we can do, we can plot both of them in same figure. So you can write this, one is by red, that red is for this one solution by 23, and then I'm writing T1 comma Z1, and say this is dotted line and say black in color. Okay, and if you want to write the legend, that legend you can also write legend. You write here ODE, first one is by ODE23, so I'm writing ODE23, second I'm writing ODE45. See, here you'll find out the solution of the given differential equation by ODE23 and ODE45. More or less it looks like same. The only difference about the ODE23 and ODE45, ODE45 is better, the approximation than of your ODE23. If you want to really find out at which point the solution is there, instead of writing this, use the the markers, and that marker will give you, instead of this you use the marker. So we have not defined any specific value for t-span, we have just given the range. So automatically it will generate the different values and it will show you the calculated result. Now if you just give you say one value, it will give you error. Let's do this. This will give you error. You must have heard this sound. Now if I am giving the three values like 0, 1 and 3, what it will do, it will do the calculation at 0, 1 and 3. So in the result you will see only 3 points. This is at t is equal to 0, this is at t is equal to 1, and this is at t is equal to 3. So if you want the result at some specific values, any random specific values, that you can give, and if you want in a range, then you simply provide the range. See, so this is all about how we can solve the first order differential equation. In the next video I will show you the solution of the simultaneous differential equation.